A very warm welcome to our Professor T.S. Dr. Zikri Abadi bin Alaruddin, and today we are going to present about the Lab 3, which is AC high voltage measurement and monitoring. And this is the group members of my team, which is Vasandan Kirajendran and Nur Shamimi binti Saberi. Okay, the objective of the lab experimental is to construct the parallel AC high voltage measurement using kit control 4.0 and picoscope 3000 series, and then we also familiarize the procedure for setting the kit control 4.0 and picoscope 3000 series, and also we compare and analyze the value obtained from the kit control reference and picoscope 3000 series display. Okay, now I'm going to present about the layout. This is the layout of the parallel AC high voltage measurement using kit control 4.0 and picoscope 3000 series. And now I'm going to explain the process of this layout. And first of all, the transformer is connected to the 100 picovolt series of the capacitor, and then the capacitor is connected using the 40 centimeter of the coaxial cable, and also the secondary unit, the secondary part, which is known as the secondary unit via the banana connector, is connected. The braided copper wire is connected to the FC cabinet kit, and also we connected to the secondary part, and also to connected to the 100 picofarad capacitor series, and also connected to the ground switching. This is the layout of the schematic circuit of this experimental lab, and can we see the power source from this transformer is connected to the 100 picovolt, and also it will be connected to the up to 19 capacitors, which is secondary unit, and it connected to the BNC junction, T junction, and also from the BNC T junction it connected to the picoscope, and from to the frequency converter kit BM1 point. This is the connection of the main part, which is the transformer. The transformer is connected to the 100 picofarad of the capacitor, and also the secondary part is connected to the banana connector, which is connected to the BNCT junction, and the capacitor also connected to the BNC T junction, which is using 40 cm of coaxial cable, and also the coaxial cable is another coaxial cable is connected to the picoscope, and also another coaxial cable is connected to the VM1 of say cabinet kit. The safety rules of action in this experimental is, first of all, it will be discharge and ground rod, which is used to manually discharge of the high voltage components, and also another safety rules, which is safety gloves, which is must ensure every time enters to the any high voltage places. It's use hand glove due to the withstand of up to 30 kilowatt.
Firstly, for section 2, I will explain about the further and the function of kit control 4.0 section, such as source control, primary side of the transformer progress, system monitoring of secondary side of the transformer with its slot, and lastly for alarm system. This is the circuit diagram for source. The three phase have to be connected to 1, 2, 3. The PE is for the ground of the input cable. If the input cable provide a natural ground, it can be connected to N, but it is not need. For input protection, there are varistors between the three phase and the PE. Next is about primary side of the transformer progress. As you can see here, the above is about a series connection of primary winding, while the below is about parallel connection of primary winding. If we do terminology series, that is 2px to 2pu, it will get 100 kV at secondary transformer. Secondary transformer is the potential from grounding point to higher point, that is 0 volt up to 100 kilovolt. If the terminology are connected in parallel, the secondary transformer will present as 220 kilovolt. Then move to system monitoring of secondary side of the transformer with 8 slots. The terminal PN1 until PN3 is terminal for measurement. They up to 7 volt RMS. There is 2 channels for AC which are VM1 and VM2, while channel 1 is VM1 slot is connected to inside the key control. The other slot which are declared as VM3, VM4, VM5 and VM6 are for DC. For now, this is the alarm schematic on how the connection for alarm which source which are the pin 7 is the common of potential free contact. For pin 8 is the switch potential free contact for the red lamp, while pin 9 is the switch potential free contact for green lamp. Next is configuration of calibration section. For this software, we just have to insert the divider ratio value that is 19651.1. Lastly, is save the setting before we start the lab session. Lastly, menu setup for picoscope. First step is name the file as kit control 300. Then for acquisition sample was set 100K at point. It is due to get the better graph for result. Next is sampling interval which is for accuracy of measurement. It is set between 5 micro to 15 micro. Also can be adjust the cursor to get the best value. For now, the preferred value is 10 micro. After that, go through with trigger active is to impulse and capture is light to turn on. Then the channel A, B, C and D is activated because the picoscope have the channel A, B, C and D. AC coupling also activate. For last, beside, auto range was activated based on the suitable of the graph. D is adjusted for value of amplitude or peak value. For divider ratio was set 19651.1 and for offset was set at 0 because x-axis is start from 0. The AC for RMS, RMC and peak also activate. Next, the channel A was activated by click the AC and the restart button was clicked to set up all the steps.
Comparison for analyzing the reference signal and display signal. The output voltage is controlled in kit control. It is located in the source control panel. This is used to control output voltage percentage. We can increase and decrease the output voltage percentage to our requirement. Here on the table, we can see that we started from 4.3% of output voltage. Then we increased to 10, 13, 17, 21.5, 26.5, 33, 38.7, 48.7, 58.7, 68.7. And finally, we decreased it to 0, a total of 12 output voltage percentages. Next, we are seeing the reference voltage. The reading is taken from reference voltage is taken from kit control. This is the reading we are getting from VM1 of the FC cabinet. We can clearly see that the reference signal increases as we increase the output voltage. Next is the display signal. The reading from display signal is taken from picoscope. If we can see clearly, the readings for reference signal and display signal are almost similar with some minor differences. The error percentage for the is calculated using the formula whereby reference signal is minused by display signal divided by reference signal times by 100. Now we can see the difference or the error margins in the reference signal and display signal. Throughout the experiment, we are using 50 Hz of frequency for the experiment. Okay, for the analysis, from the table and calculation, there are some minor error occurring between reference signal and display signal. This discrepancy is due to instrumentational error. This is because it depends on the sensitivity of the equipment to measure the value. The discrepancy also caused by the unstable power supply being injected into the system. There are various equipment which causes the unstable power supply. At 0% output voltage, the error seems to be a lot. This is caused by the residual voltage remaining in the system even after the grounding. Manual discharge is required for it to be operated safely. Next, for the conclusion, precision high voltage measurements require careful attention to the environmental conditions, the proper application of high voltage probes, and the basic functions and features of the meter. Careful selection of highly functional measuring equipment can provide broad flexibility in application, and safety must be the highest priority when handling high voltage equipment.